How's it going, Geometry Cats? Today we're looking at 10-8 geometric probability. Okay, we're gonna mix up probability, geometry. We're gonna have a little party. Okay. Quick review. Probability is your favorable outcomes, what you're looking for, over what could happen. Okay. So if I have one of these coins and I flip it, and I'm looking for heads, right? Well, there's only one head on a coin. And there's two total sides, so I have a 50% chance, a half probability of getting heads. Okay. So when we look at probability and length, let's say at a line. I'm going to drop the coin on the line, and it's random where it lands. If I was wondering where is the probability that lands on BC out of this whole segment, well, I find the length of BC, and I put it over my total. What could happen? Okay. So again, what you're looking for over what could happen. Got it? Maybe. Let's do one. Suppose you're looking at ST, and you're going to throw a point on there called K. What are the chances that K lands on QR? Okay. Well, my length QR is what? 1, 2, 3. ST equals, well, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, right? So I'm looking for QR. That's what I'm looking for. But could land anywhere from 2 to 14. So I have 12 possibilities for it to land. Okay, and 3/12 is 1/4. Or, 0.25, 25% chance. Okay, that's all there is to it, guys. Nothing tricky. Okay. A commuter train runs every 25 minutes. It arrives randomly. What's the probability that the commuter will have to wait at least 10 minutes for the train? So the train goes every 25 minutes, right? So that's the number line of time. And we want to see how long it'll take where you have to wait for 10 minutes. So that means you have to get there 15 minutes after the last train went, right? Because if you're there after 15 minutes after the last train, you'll have less than 10 minutes to wait. So this is what you're looking for, and this is your total. So you're looking for getting there after 15 minutes, possibility 25. That reduces to 3/5, okay, or 0.6. Okay. I'm going to tell you guys a joke. But remember, now in class I've heard this one yet. Suppose you have a train going 100 miles per hour east, and the other one's going 150 miles per hour west. One starts in Boston, one starts in LA. Let's say lightning hits the one train. How long will it take to reach the driver if he's a good conductor? Okay. Probability with area works the same way. We're just going to drop something in an area. We're going to say, what's the probability it lands in this area and not the whole area? Okay. So for these ones, you find the area of region N divided by the total area. Okay. It's like right now I have my Moby on the floor, on my table. Let's say I drop my pen, and it's 4 of my chances that it hits my Moby, not the desk. Well, I find the area of my Moby divided by the area of my desk. Okay. Let's try one. We're dropping a letter T, a Mr. T if you will, in a square at random. What's the probability it lands in the shaded region? Okay. Well, my total region, that area is 5 squared, because it's a square, right? It's a 5 by 5 square. So that's my total region. Now I need to find the area of the shaded region. Okay? Two ways to do that. One way is to take 25 and subtract the area of the white triangle. The other way is find the area of each triangle, or of one of the triangles, and then times it by 2. Okay? We'll do the latter. So this is what we're looking for, so this would be shaded. So I'm going to go 25 minus my 1/2 base times height. So I get 25 minus 12.5, which is 12.5. So I get my shaded region over my total area. I divide them out, get 1/2. 0.5 or 50% chance I drop it into the shaded region. And when I hawk the loogie off the building, it lands in there. Don't hawk loogies off buildings, guys. I'm a bad example. This is a tough one. Don't miss the target on this one. Archery has 5 colored scoring zones: yellow, red, blue, black. Each one is 12.2 for the radius. Okay, so what are the chances it hits the red? Well, the red zone's the second zone, right? So the radius of my red, 12.2, 12.2, right? So my red radius is 24.4. It's my radius of red. Okay? So now I have to find the area of that beast. Well, that means I'm going to have to find the area of the big circle and subtract from it the area of the yellow circle. Okay? So I'm going to do my pi times 24.4 squared equals 1,870.38. Now I need to subtract from that my yellow area. I'm going to use blue because yellow doesn't match. So I go pi r squared, because remember they said yellow's radius was 12.2. Now I'm going to subtract that from it. So I get 467.6. So I subtract them. I get 1402.78, right? So that is my red ring. This is just the red ring. So now I'm going to divide that by my total area. Now, my total area, well, if each one's 12.2, right? So that's 12.2 times 5. We have a 61 radius, right? So I do pi times 61 squared. Again, that's 12.2 times 5. So that's 11,689.8687. Okay, so I take the red ring, divide by my total. And I get around a 0.12 or 12% chance, guys. Phew! That was a tough one, wasn't it? Okay, that's it. Enjoy.